Hi everyone, welcome to lesson 2 today. This is the second lesson of our exponents and logs unit. Today we're going to be talking about transformations of exponential functions. So, transformations has a general function that can be expressed in this format here. This is going to be the same format that we generally have been working with all throughout Math 30-1. A is a vertical stretch, B is horizontal stretch, H is your horizontal translation, and K is your vertical translation. We're going to take all of those same variables and plug it right into this same equation here. So in this equation, as you notice, all the same variables are in the same positions, but the only new one that we have here is C. C is, of course, our constant term that you're going to need, and so we're going to have our vertical stretch constant term, and then up in your exponent is going to be your vertical or your horizontal stretch, horizontal translation, and then back to a normal font is your vertical translation at the end. Just a quick reminder from way back when, vertical stretches only affect your y values, horizontal stretch are only your x values, vertical translations are also y, and horizontal are always x for translations. So getting right into example 1 here, we have the base function f of x equals 4x is vertically stretched by a factor of 1/2, about the x horizontally stretched by a factor of 2, reflected on both axes, it's translated 5 to the left and 7 units up. Let's write down our function. So before I write down my function, I'm just going to list off the properties off to the side here. So it says vertical stretch by a factor of 1/2. We have a horizontal stretch by a factor of 2. We also have 2 reflections, so we have a reflection on the x-axis and a reflection on the y. We also have movement, and that's going to be 5 to the left and 7 up. So we have a horizontal translation, 5 units left, and a vertical translation, 7 units up. And there we go. Let's write down our new equation. So f of x is my original. My new one I'm going to call something different, so let's call it g of x. So what do we have for our a value? So our a value is going to be negative 1/2, because that's going to account for our reflection and our vertical stretch, so those two are done. Our constant term will be 4, so I'm just going to leave this 4 here just so that you can see it. Our b value is our horizontal stretch and the reflection, so it's going to have a negative. But remember, if I wrote a horizontal stretch by a factor of 2, it had to be reciprocated from the equation to bring it out to the descriptor there. Bracket x, we're moving it 5 to the left, so that's going to be plus 5 there. And then after all that, plus 7 down here. And so that covers off both of those as well. The mapping for this mapping will still be similar to every other mapping. So you have x comma y original, and that's going to transform into minus 2x, and because we're going to the left, minus 5, and we have our negative 1/2 y plus 7. And there we go, that's our mapping. For part C, it says if we gave you the points 216 on the original, so if xy was 216, what's going to happen on the transformed? So let's just sub in our value. So negative 2 times 2 minus 5, comma, negative 1/2 of 16 plus 7. And here we go, we end up with, this is negative 2 times 2, which is negative 4, minus 5 is negative 9 right there, and negative 1/2 times 16 is negative 8, plus 7 is negative 1. So our new coordinate, 216, became negative 9, negative 1. On this example here, we're asking you the base function f of x equals 2x is transformed into this equation here. Let's sketch our transformation. So the very first thing I notice before I start sketching is I don't have a b value here, so I'm going to quickly rewrite my g of x so that I have a b value. So g of x is going to be equal to negative 1/2 uh, constant term of 2. And here is where my b value is. It's going to be 2 bracket x minus 3 minus 5 at the end there. Now that I have a b value, if it helps, you can sketch it in. If not, then you can use your graphing calculators to do this. So loading up my graphing calculator, I get the following. So here I have 2x is going to be my y1, that's my base function, and here's that and here in y2 is my transformed equation. I'm going to hit graph once I'm ready, and I'm going to hit zoom 6 before I hit graph because I know I played around with my window setting. Zoom 6 puts it back to a normal 10 by 10. So there we have it. There's my graph. So I have my original going upwards and my second one going down. So let's pull off some coordinates. So you want to go second graph to bring up a table of values, and you want to pull off as many of these coordinates as possible, whatever can fit on your graph there. So for the first one here, we got negative 2's at a quarter, negative 1's at a half, 0 at 1, 1 at 2, 2 at 4, and 3 at 8. So let's see if we can zoom in and plug in some of these values. So 0 was at 1, negative 1 was at a half, and negative 2 was at a quarter. At 1 I was already at 2, and at 2 I was at 4. At 3 I was technically up at 8. And there we go. So we have enough coordinates here that I can connect my dots. So again, it's just going to be a straight line running above the x-axis there, and it's going to start curving up and going through all our coordinates here. And of course, you want to draw an arrowhead on each end, and this is now labeled as y equals 2x. There we go. Let's do our second graph. So our second graph here, if you notice, there's a bunch of negative 5's here. Most likely that's a horizontal asymptote. So if you scroll back down, the first coordinate that I can really plot here is 4, negative 7, and then 5, negative 13. So I'm going to try to find at 4, I'm down at negative 7. There we go. And at 5, I was at 13, so negative 7, 8, 9, 10, 11, 12, 13, so I'm quite possibly somewhere over there. I also know that I had a horizontal asymptote, and again, which number is it? It's going to be at negative 5. So our graphing calculator is not good enough to draw in a horizontal asymptote, so we need to know by theory that it's there. So I'm just going to quickly draw in my horizontal asymptote. There we go. So I know that my line needs to skip this horizontal asymptote. Okay. And again, we're just going to try our best to sketch these coordinates. At 0, we were just barely above 5 there, so here we go. Let's see what we get. And we're going through our coordinates, and it's going to shoot right up there. And it's going to just follow this horizontal asymptote, trying not to cross it. And there we go. So there's my graph, just like what we saw on our graphing calculator. So here it says describe the transformation, so let's jot down everything that we have. We definitely have a reflection on the x-axis. We have a vertical stretch by a factor of 1/2. We have a horizontal stretch by a factor of also 1/2, because we're going to reciprocate that too. We have a horizontal translation 3 units to the right. And of course we have a vertical translation that's going to be 5 units down. And there we go. Down here it says compare the domains of both functions. So if I'm looking honestly at the domain of both, so on f of x versus g of x over here, the domain for both is going to be, domain on f of x is going from negative infinity to positive infinity. So from negative infinity to positive infinity, there we go. And for g of x, it's going to be the same. from negative infinity to positive infinity. There we go. So really, there's no change in our domain. So let's take a look at our range. Even though the question doesn't ask you to compare ranges, we're going to take a look at it anyways. So the range of our original is from 0 going all the way up to positive infinity, not including 0, because we have a horizontal asymptote there. For our range here, our horizontal asymptote was at -5 and we're going downwards. So we're going down as far as negative infinity and as high as -5. And again, rounded bracket because we can't include it. Here it says identify intercepts of both functions. So what do we have? So for our f of x, did we cross the x-axis? So do we have any x-intercepts? We don't, so there'd be none. And for our y-intercept, we're intersecting this graph at 0, 1. There we go. For g of x, let's do that over here. For g of x, do we have an x-intercept again? None to report. And do we have a y-intercept? We sure do. And that y-intercept will be found right off of your calculator. So again, if you want to go to your graph, hit trace, scroll down to the next graph there, and there we go. That's going to be my y-intercept at negative 5.0078. So this is going to be 0, negative 5.0078. There you go. In example number 3, it says here the transformed function is applied to this base equation. Describe the transformations and write the new function. So let's see what we have. We definitely have a vertical stretch by a factor of 2. We have a reflection on the y-axis because that's on the inside of our function, so y-axis. We have a horizontal stretch by a factor of 4. We have a horizontal translation 8 units to the right, and we have a vertical translation 3 units up. And there we go. That's all of our description for it. So let's write down our equation for g of x here. So let's call it g of x. So what is happening to our function? So we have 2 times our base 1/2 to the exponent of negative 1 over 4 x minus 8, then all of that plus 3 to it, and there we go. We are done. In example 4 here, it says describe the transformations to go from y equals c of x to produce this function here, where c has to be greater than 1, by the way. So the very first thing I'm going to do is rewrite this equation. It's kind of messy, so I need to isolate for y. So the very first thing I do is I can either multiply both sides by negative 2 to cancel that negative 1/2 out, and that's what my first step is going to be, is multiply both sides by negative 2. So you end up with y plus 5 equals negative 2 bracket c of 3x minus 6. And of course I want to move this 5 to the other side, so now I have y equals negative 2 bracket c of 3x minus 6, and you have a minus 5 after all of that. And don't forget that we always need to factor anytime that it hasn't been factored, so I'm going to quickly factor my b value. So it should be negative 2 bracket c, you have 3 bracket x minus 2 up top there for an exponent, minus 5 at the end, and there we go. So that's our new equation. Let's write down our descriptors. What do we have? We have a reflection on the x-axis. You have a vertical stretch by a factor of 2. You have a horizontal stretch by a factor of 1/3. You have a horizontal translation 2 units to the right. and you have a vertical translation 5 units down. All right.